Let me get through attention. All right, so number 11. All right, so number 11 says, the uniform board shown in the drawing has two vertical support beams. Find the force each of the supports provides if the worker at the end has a mass of 80 kilograms and the board has a mass of 100 kilograms. Be sure to indicate the direction of each of the forces too. So, here's the board. Here is support A. Here is support B. Here is our worker. He's got a mass of 80 kilograms. What should I do with the 80 kilograms? Find the corresponding force. So 80 times 9.8 gives you the force of the worker is 784 newtons. And the problem tells you that the uniform board has a mass of 100 kilograms. So the fact that it's uniform, why did I italicize that? Why is that so important?
You don't care about the weight of the board.
You do care about the weight of the board. You absolutely care about the weight of the board. Yeah.
So the force of gravity will be in the center of it?
Good. It means that we can treat the force of gravity as being located at the center of mass. The fact that it's uniform means that that center of mass is at the center. So, all right. So here's the force of gravity on the board. 100 times 9.8 is 980 newtons. Uh-oh, I have two FBs. I'm going to make this FG as in gravity. And here's force of support B. All right, so there's my drawing. Are there questions? All right, so this is a two unknown force problem, right? So we don't know the force from either of the two supports. Everybody good with that? So, Abby, where should I pick my... Well, so what am I going to start with here? Net force or net torque?
Net force. Wait, no.
Thoughts? So if, hypothetically, suppose I did net force. So I'd have the force of A plus the force of B plus 980 plus 784 equals 0. Can you solve that? No, because there's two unknowns, right? Okay, so that's why we don't start with that. Okay, so we want to start with net torque. Question or?
Solution?
Oh, sure, yeah, we got
You just take the pivot point A or B and then make that 0 and then solve for the other one.
Yeah. So remember, anytime you have two unknown forces, you always pick your pivot point to be at one of your unknown forces. So either at A or B. It really doesn't matter which. I usually, if I can, choose the one at the end. So I'm going to call that my pivot point. You good up to there?
Yeah.
Everybody? Nobody remind me to change our attendance. How are you? Good, thank you. So the net torque around point P, right?
Yeah.
That's what we're doing. We're finding the net torque around that pivot point. Is, well, it's the torque from support A plus the torque from gravity plus the torque from support B plus the torque from the worker. If you're not doing this step, I strongly encourage it. Take a second and list all of your torques. Okay?
Wait, why do you have net torque P?
The net, it's just identifying what pivot point I chose.
Oh.
So, everybody good? Okay, and then solve it. What's our net torque got to be, guys? 0 equals the torque from A is the force of A times 0, right? Force times distance. Everybody good up to there? Abby, good?
Yeah.
Question? What's up?
No, this is just what
This is just what I do. Plus the torque from... Oh, shoot. I didn't put any numbers on my drawing. Let's do that. So let's see. The whole board is 4.7 meters. Half of 4.7 is 2.35. This distance is 3.5. And this distance is 4.7. Yes? Everybody good with that?
Wait.
Yep.
If the board bends down or up, that has nothing to do with how we calculate this, does it?
Say that again?
Andrew asked a question.
I was wondering if the net torque will ever not be 0.
Oh, I gotcha. Well, that's section 7.5. right? Where you do FD equals I alpha.
Oh.
Gotcha.
Make sense?
For like one of these, it would be like,
Yeah.
yeah, okay.
I mean, you theoretically know enough to do that.
Yeah.
You know, like maybe this cable isn't quite strong enough and it's slowly rotating. So then you'd have to do, you'd have to find the rotational inertia of the board and find the net torque. So,
That's something you'd have to do.
sorry?
Is that like a problem that?
Not for this class, no. But I mean, yeah, it's a thing that, you guys know enough to do it. It's just a lot more numbers to keep track of.
Why not?
Okay. All right, so everybody good up to here? All right, so let's see, force of gravity, so that's 980 times, what's my lever arm for that, the 980, you guys?
2.35.
0.35. Plus the torque from the board is the force of the board times just 3.5, right? Plus the torque from the worker is 784 times 4.7. And then solve it, right? Ah, I forgot my signs. AJ, what's up?
What positive, right?
Both. Oh, I gotcha. I don't know. Let's see. This is pulling down about this pivot point. That's clockwise. So remember, clockwise is negative. So I'm going to make this guy negative, and I think for the same reason the worker is negative also.
Why do you not have the thing for FW? You stopped at B.
I just put it down on the next line.
Oh.
I ran out of room. You good?
Yeah.
Everybody good? All right, so solve this, and you end up getting that the force of the board times 3.5 is positive, whatever that number is. Positive big number. All right? And then you divide both sides by 3.5, right? Now, very, 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 very important question. Algebraically, when I solve this, because this is positive, my force is going to come out positive. Does that necessarily mean that my force has to be upward?
No.
Not always. All right, in this one it happens to be, but it's not always. So the way you should interpret this is you should think the torque from B is positive, which means counterclockwise, right? Does that make sense? So if this is my pivot point, which direction does the force from B have to be to provide a counterclockwise torque? Let me say that again. If this is my pivot point, and I know force B is going to make a counterclockwise torque, do I have to push up or down to get clockwise? Up, right? So that's how I know that force is up. Make sense? I'm still seeing people assuming that the sign on the torque is the same as the sign on the force, and you cannot do that. Cool? All right. So once you solve this, you find out that the force from that board is whatever I said on the sheet. Oh, you know what? I'm dumb. I have all these worked out. Here. So this positive big number that I was being lazy about is 5,987.8, if you are keeping score. And so the force turns out to be 1710.8. Good? Any problems? So, 1710.8 newtons up. So how do I find the force of the other support, you guys?
Oh, 7 equals 0.
Set your net force is equal to 0, right? Or net force. I don't know why I said net forces. So now I can do this. My net force is the force of A plus the force of gravity plus the force of B plus the force of the worker. That's a W. My net force is 0. Force of A we don't know. Force of gravity is now I make that negative, right? Because the force of gravity is downwards. The force of B we just found at 1710.8. Force of the worker is 784. And solve. And then you're done. Yes, sir?
How would you go about it if it wasn't uniform? Or were we not worrying about that?
If it was not uniform, then I would have had to have told you where the center of mass was. So I
And
would
we
have
just
said,
make that whatever.
yeah. So maybe I'd say, the worker stands on a board. Whatever. The board has a center of mass 1 meter from support A or whatever.
So it's just no different. It's no different spot.
Yeah, just a different spot. Yep. AJ, and then Andrew.
Is it bad that, like, I just solved that. Is it bad that it's, like, really small compared to the other one?
No. What's that telling you?
It's not in context.
It's relatively balanced with that.
Good. Yeah, it's pretty close to being balanced without force A being here at all. In other words, the weight of, if you think of this as being your pivot point, then these two forces have it pretty close to being balanced, but the support has to put in a little bit of support to prevent it from flipping. Cool? Yeah, Andrew, I'm sorry.
Here, then your tricks for like where to put the pivot point, where
So if there are two unknown forces, you pick the pivot point at one of the two unknown forces. Which one doesn't really matter?
Oh, I thought that was like a trick.
No, not really. I usually, if I can, I do the one like if there's one at a far end, I usually pick that one, but it doesn't really matter. And then if there's an unknown distance, I almost always just pick it at the end. All right, everybody good with 11? All right, cool. What else you guys want to look at?